Hello students. So today we'll be doing a new chapter and we'll be revising all the contents related to that chapter. The chapter name is Electrostatic Potential and Capacitance, and I'll be discussing numericals also. I'll be discussing the concepts also, and I'll try to cover all the important concepts in one video in almost 1 hour. So let's start. So the first topic is electrostatic potential. First we have to discuss electrostatic potential. Now whenever we discuss electrostatic potential, what is electrostatic potential basically? In simple terms, it is basically the work done by electric field to take 1 coulomb charge from one point to infinity. Whenever electric field, any source charge is creating electric field, and whenever any electric field takes a 1 coulomb charge from a particular point to infinity, then amount of work done per unit charge is basically called as what? Electrostatic potential. So let me write it. So basically what I'm trying to say is, suppose there is a source charge and this source charge has created an electric field and I want to find the potential at this particular point. So what I will calculate is, what I will do, I'll take 1 coulomb charge, I'll take this point as infinity, I'll take 1 coulomb charge from P point to infinity, and now whatever is the work done by the electric field, remember my words, whatever is the work done by the electric field to take the charge from that particular point to infinity, that is basically the potential at this point. So basically what will be the potential at point P? It will be equals to work done by electric field to take 1 coulomb charge from P to infinity. Okay, this is basically the concept of electrostatic potential. If I am taking q coulomb of charge, suppose if I am taking q coulomb of charge, so potential at point P can be written as work done by electric field to take the charge from P point to infinity divided by the value of q naught. Suppose instead of taking 1 coulomb charge, I am taking q coulomb charge, q naught coulomb charge from P point to infinity, then in that case, work done by the electric field to take this q naught charge from P to infinity divided by the value of q naught will give me the potential at that point. If q naught becomes 1 coulomb, then this definition will hold. So this is basically the actual definition of potential. It is a scalar quantity, everything we already know. It is a scalar quantity and the unit will be what? It will be joule per coulomb. So let me write it as scalar. Potential is a scalar quantity. What will be the SI unit? SI unit will be joule per coulomb or volt. So we will write the unit of potential as volt. I hope this is clear to you. Achha, one more thing, potential at point P can also be written in one more way. Whatever is the work done by electric field to take the charge from P to infinity, that can be written as negative of work done by external agent. So what I can write is that if external agent is also present, in that case, work done by external agent plus work done by electric field will be equals to change in kinetic energy. Yes. Now, if particle is taken slowly, in that case what I can write? I can write change in kinetic energy to be equal to 0. So in that particular case, what I can write is that the work done by external agent to take the charge from P to infinity will be negative of work done by electric field to take the charge from P to infinity. So you can write it, this particular thing, in terms of external agent also. But remember only one definition of potential, that it is the work done by the electric field to take the charge q naught from P point to infinity divided by the value of q naught. Simple terms, you can write like this. Now based on that, I have a numerical also. Please understand this. So the numerical says that you have a system of charges which has created its own electric field, and they have said that to bring q naught is equal to 5 millicoulomb. So this is the charge 5 millicoulomb. You have to bring this charge from infinity to point P, and you have to bring it slowly. Slowly means that there is no change in kinetic energy, and they are saying that in that case the work done by external agent is how much? 0.5 joule. So you have to find the potential at point P. So what I told that potential at point P can be written as what? Potential at point P can be written as work done by electric field to bring the charge from P to infinity divided by the value of Q naught. Yes or no? But they have said that the work done by external agent to take the charge from infinity to P is given. So how can I write? I can also write work done by electric field as negative of work done by electric field to take the charge from infinity to P divided by Q naught. Yes. Now this can also be written as negative of work done by electric field is basically work done by external agent. Just now I told that work done by external agent is basically negative of work done by electric field to take the charge from one point to another. So it can be written as work done by external agent to bring the charge from infinity to P divided by Q naught. Now, do you know what is the work done by external agent to take the charge from infinity to P? Yes, you know 0.5 joule. And do you know the value of Q naught? Yes, you know 5 millicoulomb. So potential at P will be equals to how much? It will be equals to 0.5 divided by 5 into 10 to the power minus 3. So this is how you can basically write this particular case. So what will be the potential? It will be 0.1 into 10 to the power 3, that is 100 volt. This is how you can calculate the potential at that point. Similarly, they are asking work done by electric field to bring Q naught is equal to minus 3 millicoulomb charge from infinity to P is 6 joule. Find the potential at P. Again, now they have written in terms of electric field. So again, you can find this is a very simple question. So what will be the question? What will be the answer? Potential at point P will be equals to, I know only one point. What they are saying, work done by electric field to bring Q naught from infinity to P is 6 joule, and this is the work done by electric field. So what I will write? I will write potential at point P is work done by electric field from P to infinity divided by Q naught, that is negative of work done by electric field from infinity to P. Achha, why I am writing like this? That from P to infinity is negative of work done by electric field from infinity to P, because in a closed path, from P to infinity and then from infinity to P, in a closed path, the work done by the electric field will be 0. Why it is 0? Because it is a conservative field and the work done in the closed path is basically 0. So it will be minus of work done by electric field from infinity to P divided by Q naught. Now, do you know what is the work done by electric field from infinity to P? Yes, it is there. It is 6. So it will be minus 6 divided by Q naught will be how much? Q naught is minus 3 millicoulomb. Always put the charge with sign. So it will be minus 3 into 10 to the power minus 3. So this will be 2 into 10 to the power 3 volt. So this is how you can calculate the values of these particular quantities based on this simple definition of electrostatic potential. I hope it is clear. Let's move to the next concept. Next concept is electrostatic potential due to a point charge. So how to calculate the electrostatic potential due to a point charge? So this question also is similar question only. Try to do this question. I've given you, try to do this question on your own, you will be able to get the answer. Next is electrostatic potential due to a point charge. What is the electrostatic potential due to a point charge? It is very simple. Suppose there is a point charge which is kept here Q, and let us suppose I want to find the potential at this point. Suppose the distance from here to here is R. Then the potential at point P will be given by KQ divided by R, where obviously Q has to be put with sign. You should put the value of Q with sign. And one more thing which I want to tell is that potential here is inversely proportional to R. So potential due to a point charge can be written as KQ by R. Q has to be put with sign. If it is a positive charge, it will be positive potential. If it is a negative charge, it will be negative potential, and the value will be KQ by R. Derivation is not required right now. You just have to remember the results. Achha, one more thing. Whenever you want to write the potential at a point, always remember first you have to define the reference. So the reference I am taking at infinity to be 0. I am assuming in all these cases that the potential at infinity is basically considered as 0. Then only I can write these points. So based on that, there is a simple question, and that question is saying that there are charges Q, 2Q, 3Q and minus Q, and you are required to find the potential at the center, potential at A and potential at B. So we can do this particular question very simply. let me take one page so that you understand clearly. So what they are trying to tell is that there is basically a square, and on that square Q, 2Q, 3Q and minus Q charges are kept, and they are asking you to find the potential at different points. The square is having side A. The square is having side A. So how you will find it? The first part will be you have to find the potential at the center. So for finding the potential at the center, it is very simple. Every charge is at the same distance, that is basically A by root 2. So potential at the center will be what? K divided by A by root 2. In the bracket, you can add the charges. Always remember, for writing the potential due to multiple charges, you have to just do the scalar addition of the potential due to the single charge. So how you will do it? You will directly write K divided by A by root 2 multiplied by all the charges summation. So 2Q plus Q plus 3Q and minus Q. Obviously, you have to put it with sign. So QQ will cancel out. You will get 3 plus 2, 5. Answer will be K into 5Q divided by A by root 2. So what will be the answer? It will be 5 root 2 KQ divided by A, where K is 1 upon 4 pi epsilon naught. This is the potential at the center. They are also asking you the potential at this particular point. Potential at this point they are asking. Potential at A, and this distance is given to you as A by 2. So how you will find it? Please understand. See, due to this Q and due to this minus Q, at this point the potential will cancel out, because this will create a potential of KQ divided by A by 2 and this will create a potential of minus KQ by A by 2. So they will cancel out each other, and due to these two it will add. So we have to find the distance. This is very simple. This length is how much? A by 2. This is A. So this length will be how much? It will be under root of A square plus A square by 4. So this will be basically root 5 A by 2. The same distance is for 2Q also. So if I want to find the potential at point A, I will directly write K into 2Q plus 3Q will be 5Q divided by root 5 A by 2. So what I am getting? I am getting 2K Q divided by root 5 multiplied by A. This is the final answer which I am getting. So I hope this particular point is clear to you. I think there is some mismatch here. This will be 2KQ divided by A multiplied by root 5. This will be the answer. 2 root 5 KQ by A. So this is how basically you can do these questions. So for multiple charges, you have to do only one thing. What is the one thing which you have to do? You have to just add the potential due to the individual charges. Now, if you want, you can try this question also. There is a uniform rod and it has been given charge Q and length L, and the charge density is lambda is equal to Q by L. You have to find the potential at point P. So here how you have to do it? Again, a very simple task. From here, you will take at a distance x, you will take a small element of length dx, and for this you will find the dq charge. So dq will be lambda dx, and due to this dq charge you will find the small potential at point P, that will be k dq is lambda dx divided by the distance is x. This is basically the small potential. Now if you want to find the potential due to the entire rod, you will integrate it, and from where to where you have to integrate? From x is equal to a to x is equal to a plus l. You will integrate it and then you will get the final potential. So this will be a very simple task. You can do it. Let me directly do it. It will be k lambda 1 by x integration will be ln x from a to a plus l. Please solve it. You will get it as k lambda into ln of a plus l divided by a. So this is how you can find the potential due to a system of charges also. Next is electric potential due to a ring. So if I talk about electric potential due to a ring at the center, so at the center, if you want to find the electric potential, suppose the ring is having charge Q and the radius is R, then the potential at center will be directly given by KQ divided by capital R. Directly you can remember. If you want to find at the axis, so at the axis, suppose this is a ring and it is having charge Q, and suppose the radius is R, and you want to find the potential at this point at the axis at a distance x. So at a distance x, the potential will be given by how much? It will be kq divided by under root of capital R square plus xy. See, these terms you have to remember only. Okay, because right now derivation is not that much important. Just remember the results, you will get the answers. That at the center of the ring, the potential is kq by r, and at a distance x from the axis of the ring, the potential will be kq divided by under root of r square plus x square. So let's move in the forward direction. So based on that, I have one question here. Let's discuss that question. A very simple question we have to discuss. They are saying that there are two rings, coaxial rings. Coaxial means the axis is same. And in this two coaxial charged rings, one ring is having charge q radius r, another ring is having charge 2q radius 2r. And you have to find the potential at point A, potential at point B, and potential VA minus VB. So how you will do it? So let me take VA here. Potential at point A will be how much? Potential at point A will be equals to how much? Potential at point B will be equals to, because of this ring it will be kq divided by capital R, and because of 2q ring it will be k2q divided by this distance we have to take na, from A to this point. So it will be under root of this radius was 2r na, so under root of 2r whole square plus x square. This will be the potential at point A. Very simple. Because of this ring, this point is the center of the ring, and because of this ring, this point is the axis of this particular ring. So I have applied the formula and got the answer. Similarly, if I want to write potential at point B, what I will write? Potential at point B will be equal to, due to the ring center, it will be k 2q divided by 2r, and because of this ring at this point, it will be kq divided by under root of r square plus x square. So once you have got the potential of B and potential of A, then you can directly find VA minus VB also. It will be just the subtraction of the individual results. Then as potential due to a uniform spherical shell, which is a hollow sphere. How you will calculate? Very simple. You have to just remember the results. For a hollow sphere, let me write it on the next page. Whenever you are having a hollow sphere and radius r, charge q is distributed here. So remember one thing, that for small r greater than capital R, where small r is basically taken from the center. So for small r greater than capital R, the potential at any point P will be given by kq divided by small r. Matlab you can take the entire charge to be concentrating at the center. For small r equal to capital R, it will be potential at surface. Potential at surface, that will be equals to kq divided by capital R. And for small r lesser than capital R, potential at any point inside will be equals to potential at surface. It will be a constant value. And what will be the potential at surface? I already know kq by capital R. So inside everywhere, any point you take, not just the center, any point you take, the potential at any point will be equals to kq divided by capital R. It will be equals to the potential at the surface. They can also tell you to draw the graph of potential versus small r. So graph also you must know. So V versus R, if you take, then for 0 to capital R, the potential will be equals to potential at surface. It will be a constant potential, and then it will be inversely proportional to small r. So this graph is also important. You can remember this result. So this was basically the potential due to a uniform spherical shell. I have taken one question also for calculating this. So they are asking you VA and VB, and they have given you some data. So let me take the question here only. The question which they are asking is this. They are saying that there are two spherical shells. There are two spherical shells. One is having radius r1 and the another is having radius r2. On this charge q1 is there and on this charge q2 is there. And they are asking you to find the potential at A point and B point. And this point is basically point B and this point is point A. So VA and VB they are asking. So how you will calculate? Very simple. Potential at A, if you want to calculate, you just think about this charge. For this spherical shell, for this Q1 shell, this A point is outside point. So you will apply outside wala formula. So what you will write? You will write potential at A is equal to K Q1 divided by R2. K Q1 divided by R2. And for Q2, this point is basically surface point. So you will write K Q2 divided by R2. How to write the potential at point B? For this charge, it will be the surface point. So K Q1 divided by R1. And for this charge, it will be the inside point. And whatever is the potential on the surface, that is the potential on the inside. Potential on the surface was this only. So this will also be equal to KQ2 divided by R2. And then if they will ask you to find the potential difference, you can do VA minus VB and get the answers. So I hope that this particular point is clear to you. Next, they are asking you to find the potential due to a uniform solid sphere. So this also let me tell on this page only. So for uniform solid sphere, what you will do? Suppose you take a uniform solid sphere. Obviously, this will be the center and the charge will be distributed uniformly. The charge will be distributed uniformly. Suppose the radius is R. Again, for small r greater than capital R, total charge is how much? Total charge is Q. So for small r greater than capital R, the potential outside will be K capital Q divided by small r. There is no problem. Just as spherical shell, this will also be the same. For small r equal to capital R also there is no problem. Potential at surface will be equal to KQ divided by capital R. But if you take any point on the inside, suppose you take any point on the inside, then inside points where small r is lesser than capital R, on the inside points, the potential will be given by KQ divided by 2 capital R cube into 3 capital R square minus small r square. So please remember the result. The result is important, KQ divided by 2 capital R cube into 3 capital R square minus small r square. Now if you put at center, so at the center potential or small r will be equal to 0. So potential at the center will be 3 by 2 KQ divided by capital R. That is nothing but 3 by 2 times the potential at surface. So this is also very important point which you have to remember. Now if you draw the graph between V versus small r, then please remember that for this is the potential at center, this is the potential at surface. From center to surface, it will be a downward parabola and then it will be a rectangular hyperbola. So this part is downward parabola. D parabola means downward parabola, and this part is rectangular hyperbola. So I hope this result is clear to you. Remember all these results, they are very important. You have to remember these. Chalo. So we have done the electrostatic potential due to a uniform solid sphere also. We have completed this also. We have completed this part also, and we have completed the potential due to a the ring also, at center also and at axis also. Now electrostatic potential difference. What is the meaning of electrostatic potential difference? Very simple to understand. Suppose again you are having a system of charges. And there are 2 points, point A or point 1 and point 2. Suppose the potential at point 1 is V1 and the potential at point 2 is V2. Now I want to take the charge from Q charge I want to take, or Q0 charge I want to take from point 1 to point 2. So what is my initial point? Initial point is from where I am taking the charge. What is my final point? Final point is to where I am taking the charge. So if they will ask you potential difference, so potential difference is basically V final minus V initial. But how to write this particular potential difference? I write it in this format. Please remember, I will write V1 minus V2. I am taking the charge from point 1. So first I will write V1. Then I am taking to point 2, then I will write V2. So if I am taking the charge from point 1 to point 2, I will write V1 minus V2. This is not the potential difference. Potential difference is V2 minus V1 because final is 2 and initial is 1. But how I write it, if I am taking the charge from 1 to 2, I will write V1 minus V2 is equal to work done by electric field to take the charge from point 1 to point 2 divided by whatever charge you are taking Q0. Simple. I learn this particular result. Now, if somebody will ask me potential difference, what I will write? I know that final potential is V2. So I will write V2 minus V1 as negative of this. So I will write minus of work done by electric field to take the charge from point 1 to point 2 divided by the value of Q0. So this is how I remember this particular result. This is the potential difference between any 2 points in electric field. So let me discuss one important point, that whenever we want to write electric potential difference due to a uniform electric field, then also this will be like this only. Work done by electric field from point 1 to point 2 divided by Q naught will give you V1 minus V2. I hope it is clear to you. Chalo, let's discuss this particular result. Electric potential difference due to uniform large sheet. So obviously we know that the uniform large sheet will create a uniform electric field. So whenever we have a uniform large sheet, suppose positive charge is given to it and the charge density is sigma coulomb per meter square, then the electric field in this region will be equals to sigma divided by 2 epsilon naught. Now suppose I take point 1 here and point 2 here and they are separated by a distance d. So how will I write V1 minus V2? V1 minus V2 will be equals to, कैसे लिखेंगे? V1 minus V2 will be equals to work done by electric field to take the charge from where to where? 1 to 2 divided by the value of Q naught. Suppose I am taking Q naught charge from point 1 to point 2. Acha, the path of Q naught does not matter. I can take the charge along any path. The path will not create any difference because work done by electric field is basically path independent. It is the conservative force. So this is how I will write. So कैसा हो जाएगा? What I will write? Work done by electric field will be equals to what? I know that for constant electric field, the force will also be constant. So the work done can be directly written as charge force multiplied by displacement. So force will be how much? Q naught into sigma divided by 2 epsilon naught. This is force multiplied by displacement from 1 to 2 is d, and divided by, I will divide it by Q naught also because Q naught I have to divide. So this will be cancelling out. I will write sigma by 2 epsilon naught multiplied by d. That means whenever I am in a uniform electric field, I can directly write V1 minus V2 as the electric field E multiplied by the displacement in the direction of electric field. Always remember, in the direction of electric field, we have to find the displacement. Understood the logic? Similarly, I can write the electric potential difference due to a uniform large wire also, but here I have to integrate it. Here I have to integrate because if a uniform large wire is there, suppose its charge density is lambda coulomb per meter, and let us suppose I take 0.1 here and I take 0.2 here. I take 0.2 here. So you can take 1 coulomb charge also if you want. 1 coulomb charge you are taking from 0.1 to 0.2. Electric field is in the radial direction, we already know. For this particular configuration, electric field is given by 2k lambda by r. Suppose 0.1 is at a distance of r1 and 0.2 is at a distance of r2. So what I will write? I will write potential V1 minus V2 will be equals to work done by the electric field. I am taking a 1 coulomb charge only. So I will write 2k lambda by r. 2k lambda by r multiplied by displacement. Suppose I take dr displacement. And then I will integrate it from where to where? From R1 to R2. So if I will solve it, I will get the answer. V1 minus V2 is equal to 2k lambda will come outside. 1 by R will be ln R, ln of R2 divided by R1. This is how I will calculate the potential from one point to another point. I hope it is clear to you. The next concept is relation between electric field and electric potential. See, all the things I am trying to cover everything quickly so that you are able to practice more and more number of questions. So the next concept is relation between electric field and electric potential. What is the relation between electric field and electric potential? I already told you all the things. Please understand. Let me take the next page. If suppose there is a point 1 and there is a point 2 and I want to take charge from 1 point to 2 point. Suppose I take Q naught charge only. So how will I write? I will write V1 minus V2 is equal to work done by electric field to take the charge from 1 to 2 divided by Q naught. Work done by electric field can be written as integration of Q naught E vector dot dr vector from 1 to 2 divided by Q naught. So Q naught will cancel. I will get V1 minus V2 is equal to integration E vector dot dr vector from point 1 to point 2. Always remember, if electric field is given to me and I want to calculate V1 minus V2, when I am taking the charge from point 1 to point 2, then directly I can calculate integration E dot dr and I will be getting the answers. This I can write it in one more format. V1 minus V2 can be written as integration Ex into dx from 1 to 2 plus integration Ey into dy from point 1 to point 2 plus integration Ez into dz from point 1 to point 2. Now whatever components of electric field are given to me, just put it there, integrate from point 1 to point 2, and you will get the value of V1 minus V2. This is one format of questions which can be asked. Another format of questions which can be asked is that, let us suppose if I say to you that potential as a function of x comma y comma z is given to me. Potential as a function of x comma y comma z is given. Now if this potential is given to me, then if I want to find the value of electric field, please understand, if I want to find the value of electric field, then Ex can be written as minus del V by del X. Del means partial differentiation. I think in work power energy also you would have done. So we have discussed already that. Ey will be equals to what? It will be minus of del V by del Y, and Ez will be equals to what? Minus of del V by del Z. So based on this, you can directly calculate the electric field values, and then vectorially electric field will be Ex I cap plus Ey j cap plus Ez k cap. So I hope this point is also clear. So based on this, I have a question. Suppose if I say to you that potential is given as x square minus yz. I want to find the electric field at 1, 2, 3. Potential is given as x square minus yz. I want to find the electric field at 1, 2, 3. So how will I find? I will find Ex first. Ex will be minus of del V by del X. I will differentiate this term with respect to x by keeping y and z constant. So I will get 2x. And since I want to find the electric field at 1, 2, 3, so put x is equal to 1 here, I will get minus 2. Ey will be equals to minus of del V by del Y. So I will get it as minus of, with respect to y I will differentiate, so x square will be 0, and with respect to y I am differentiating, so it will be minus z, so it will be plus of z. And z is equal to how much? 3, so it will be 3. And Ez will be equals to minus of del V by del Z. So if I will differentiate it, what I will get? X square will be 0, minus of, I will write minus y. So this I will get it as plus y, and y is equal to 2, so I will get 2. So my answer is coming out to be electric field is equal to minus ka 2 I cap plus 3 j cap plus 2 k cap. So I hope this point is clear to you. This is a very simple question based on which we can find the answers. One question I have given for you homework. Please try to find it. Electric field is given to you. Potential at 1, 2, 3 is given. You have to find the potential at 2, 3, 4. Please calculate it. You will be able to get the answer by the basics which I have already told. Okay, let's move to the next concept. And the next concept is equipotential surface. Now, what are equipotential surfaces? This is a theoretical topic. Let me just quickly brief you like this only. Equipotential surfaces are those surfaces in which the potential at each point of the surface is constant. So what are equipotential surfaces? Potential at each point of the surface, at each point of surface is constant. Or I can also say that potential difference between any 2 points, you take any 2 points on the equipotential surface, the potential difference on any 2 points will be equals to 0. This is called as equipotential surface. Always remember, if potential difference is 0, then the work done by electric field will also be equal to 0. That means if you take any charge from one point to another point and you are taking that particular charge on the equipotential surface, then the work done by the electric field will also be equal to 0, and similarly I can say work done by external agent will also be equal to 0. One more thing which you have to see is that on equipotential surface, the electric field lines are perpendicular to equipotential surface. Always remember, electric field lines are always perpendicular to the equipotential surface, because if the electric field lines will be at an angle to the equipotential surface, then obviously there will be one component along the surface due to which there will be movement of the charges. So this cannot happen because we are taking the electrostatic condition. So always remember, equipotential surfaces, electric field is always perpendicular to that. I hope you have understood this. Okay. Acha, one more thing. Two equipotential surfaces cannot cancel each other or cannot intersect each other, because if two equipotential surfaces will intersect each other, then at that particular point there will be two directions of net electric field, which is not possible. Net electric field can only have one direction. So that is why these are some properties which are basically you have to remember for equipotential surface. Now, whenever you talk about equipotential surfaces like point charge, so for point charges, always remember, for point charges, the equipotential surface are concentric spheres. Concentric spheres. You have to remember these results. For large sheet, these will be parallel planes. Large sheet, these will be parallel planes. And for infinite wire, the equipotential surfaces will be concentric cylinders. Equipotential surfaces will be concentric cylinders. I hope this is clear to you. So these are the basic concepts which are basically based on equipotential surface. Now one more thing, I have given a particular question in which what I have done is, if you see properly, if you see that these are basically lines, 30 volt, 10 volt, minus 10 volt and minus 30 volt. So these are basically the equipotential surfaces. These are planes which I have given, and every plane is having a particular potential. Like this particular first plane is having 30 volt, then 10, then minus 10 and minus 30, and they are inclined at an angle of 37 degree. They are inclined at an angle of 37 degree. This point is given as 0, minus 10. This is 0, 10. They are asking you the electric field in this region. So first of all, tell me what will be the direction of electric field. We already know the direction of electric field will be perpendicular to the equipotential surface. If it will be perpendicular to the equipotential surface, then obviously the direction and electric field goes from where to where. I already know that electric field always will go from higher potential to lower potential. So this is higher potential, this is lower potential. So the electric field will be going like this. So this is how electric field will go. We have already calculated the direction. Just calculating the magnitude is very simple. You can take any 2 points. Suppose you take 1 point here, 1 point here, 1 and 2. So V1 minus V2 will be equals to what? Electric field multiplied by this distance. So let us call this distance as D. I will write it as D. V1 you already know 30 volt, V2 you know 10 volt, and distance also you can calculate. By you already know this distance now. From here to here you know this distance, and this angle also you know. So you can calculate this value of D. You put it here, you will get the value of magnitude of electric field. Okay, so this is how you can proceed. So I hope this particular concept is also clear to you. Now let me discuss the next concept, and that is electric potential energy. So what is electric potential energy? In simple terms, if I will say electric potential energy, see what was the concept of potential? The concept of potential was, it is work done by the electric field to take the charge from P to infinity. Or I can also say that it is work done by external agent to take the charge from infinity to P very slowly. And we have to take 1 coulomb of charge from infinity to P. Electrostatic potential energy, there will be only one difference. The difference will be that now you have to take the charge from infinity to P, and that charge has to be Q coulomb of charge. Are you understanding my concept? Initially, potential, when I am discussing, potential was work done by external agent to take 1 coulomb of charge from infinity to P. Here, potential energy will be work done by the external agent to take Q coulomb of charge from infinity to P very slowly. I can also define potential energy in one more format, that potential energy is basically the energy of the system or the work done by the external agent to assemble a particular system in a configuration. So if I want to make a configuration of charges, an arrangement of charges, whatever work external agent has to do to make this configuration very slowly from infinity, that is basically called as potential energy of the system. So let me just brief this particular concept, that what is basically potential energy. It is basically the work done by external agent to bring Q0 charge from infinity to a point against electric forces very slowly, and electric potential energy is defined for the system. Always remember, electric potential energy is always defined for the system. Now how to calculate the potential energy? Please understand, it is very simple to calculate potential energy, because now we already know the potential. So due to a system of charges, if at some point P there is some potential V, then the potential energy can be directly given by, or change in potential energy can be given by, Q into delta V. Suppose you are taking the charge from infinity to P, and infinity we always assume potential energy to be 0, and we assume potential to be 0. So if we assume this particular condition, then in that case potential energy at any point can be written as Q multiplied by the potential at that point. So it is very simple to calculate potential energy of a system. Just calculate the potential at that point where you are taking, where you are bringing this Q charge, and then multiply that potential with the value of charge which you are bringing from infinity to P. You will be able to get the potential energy of the system. Now there are some points which you have to remember, that potential energy's unit will be joule. It is a scalar quantity, and one more unit is there, that is electron volt, that mainly you will use when you will discuss modern physics. So in modern physics also you will use one unit, that is 1 electron volt. 1 electron volt is basically 1.6 into 10 to the power minus 19 joules. Then potential energy, because it is a scalar, it can be positive, it can be negative, it can be zero. Generally we assume the potential energy at infinity to be zero, generally, but potential energy can be assumed anything else also. So now electric potential energy of 2-point charges. Very simple to understand. Suppose there are 2-point charges, point charge Q1 and point charge Q2, and they are kept at a distance r from each other. And if I am assuming that the potential energy at infinity is assumed to be zero, then the potential energy to assemble this system is given by, potential energy of the system will be given by K Q1 Q2 divided by R. I am not deriving this because time is limited. So directly I am giving you the result, that if you are having two charges and they are separated by a distance r, then the potential energy of the system will be directly given by K Q1 Q2 divided by R. And here please remember that Q1 Q2 has to be put with sign. So there is a very common term, that if you decrease the separation between the charges, will the potential energy increase or decrease, or depends on the sign of charges? So basically it depends on the sign of charges, because if both the charges will be positive and you decrease the distance, R will decrease, so potential energy will increase because there is positive sign here. But if one positive, one negative, potential energy is negative. Now if you will decrease R, negative potential energy will increase, but overall though it will decrease only na. If negative numbers are increasing, overall it will decrease. So it depends on the sign of the charges to discuss this particular question. I hope it is clear to you. So let's go to the next concept, and the next concept is basically some questions which you can do. The first question is that there is a charge capital Q, and I think it will be not visible to you, so I am just dictating it. Plus Q charge is there, it is fixed, and there is another charge small q, mass m. You have released this charge from here. They are asking you that when this, and initially the distance was r, they are asking you that when this particular charge will repel with this charge, after some time the distance from here to here will become 2r. Now you are being asked that what is basically the speed of the particle. The speed is being asked. So how you will do it is very simple. You can apply energy conservation. Can you apply momentum conservation here? No, momentum conservation you cannot apply. Why you cannot apply? Because this charge is fixed. So there will be some external force who is basically helping it to get fixed. So you cannot apply here momentum conservation, but energy conservation can be applied because only electrostatic force is doing work. So basically how you will write? You will write U plus K initial will be equals to U plus K final. What is the initial potential energy between the charges? It will be K capital Q small q divided by R. Initial kinetic energy is 0. Final potential energy will be K capital Q small q divided by 2R, plus final kinetic energy of this particle will be half mv square. From here please calculate the value of V. V will come out to be under root of K capital Q small q divided by mr. So this is how you can calculate, you can use the concept of potential energy of 2-point charges by this format. In the same way, this type of questions are also there. Please try to do these questions on your own. I've written the solutions also so that you can understand the complete concept. Chalo. Now let us discuss this concept, that if potential energy of a system of charges is given. Right now though I have taken potential energy only due to 2-point charges. But let us suppose if potential energy of a system is given, then how you will calculate? So that is also very easy to calculate. Suppose you are having a system of 3 charges and they are placed on the equilateral triangle side A, and they are asking you to find the potential energy of the system. So it is a very simple task to calculate it. Just what you have to write is, you have to write K, you have to take the pairs only. So suppose you take Q1 and Q2 one pair, Q2 Q3 will be another pair, Q3 Q1 will be another pair. So how you will write? K Q1 Q2 divided by A plus K Q2 Q3 divided by A plus K Q1 Q3 divided by A. So 3 pairs will come. In the same way, you can find for 4 charges also. What will be the potential of the system? So it will be K Q1 Q2 divided by A plus K Q1 Q3 divided by root 2A. Why root 2A? Because Q1 and Q3 are separated by root 2A distance. Plus K Q1 Q4 divided by A. Similarly for Q2 you will write K Q2 Q3 by A plus K Q2 Q4 by root 2A. And finally you will write for Q3, it will be K Q3 Q4 by A. So how many pairs are there? 1, 2, 3, 4, 5, 6. 6 pairs will be there, and this is how you will find the potential energy of the system. So for multiple point charges also you can find easily the potential energy of the system. Okay, now let's go to the next concept. How to write the electric potential? These are some more questions which I have taken, in which you can use the concepts whatever I have told. Please do these questions. I have taken these questions for you to practice. So solve karna, try to solve these questions, you will be able to do it. Now for the next case, electric potential due to a dipole. Whenever we are discussing a dipole, then dipole also there are 3 points. One is on the axis of dipole. See, I am not deriving it right now. Derivation already I have written. If you want, you can see from here. You will be able to get the answer. Just you have to remember the result. So when I will discuss potential due to on the axis of the dipole, the potential on the axis of the dipole will come out to be Kp divided by r square minus L square. This is the potential due to the dipole, Kp divided by r square minus L square. Now for short dipole means when r is much greater than L, then you can basically neglect this value of L, then the potential will come out to be Kp by r square. So for short dipole, what you will write, it will be approximately Kp divided by r square. You have to remember this result. On the equatorial axis, on the equatorial line, that is a perpendicular bisector line, the potential will come out to be 0. Because the distance from minus q charge to this point and plus q charge to this point, the potential will be same, and it will be equal and opposite. That means one will be positive, one will be negative. So the overall potential will come out to be 0. If you talk about the general point, then in the general point, you have to always resolve your dipole. Achha, general point is always considered, please remember, for general point you have to always consider a short dipole. So suppose at a distance r, I have a point which is point A, and it is making an angle theta. It is making an angle theta with this particular line. So what I will do is, I will resolve this dipole in 2 parts. One will be P cos theta, one will be P sin theta. For P sin theta, this point is the equatorial point, so the potential will be 0. For P cos theta, it will be an axial point, the potential will be Kp cos theta divided by r square. I can also write potential at A as K P vector dot r vector divided by r cube. So wherever P vector dot r vector will be positive, potential will be positive. Wherever P dot r will be negative, potential will be negative. Okay, so based on this, basically this you have to remember all these things. Okay? Potential energy of the dipole placed in uniform electric field. If you are having a uniform electric field and you place a dipole of dipole moment P in this electric field, you will get the potential energy as minus of Pe cos theta or minus of P vector dot E vector. Again, very important result you have to remember. Here there are 3 cases. If theta becomes equal to 90 degree, potential energy will be 0. If theta becomes equal to 0 degree, potential energy will be minus Pe, and that will be the minimum potential energy, and that situation corresponds to a stable equilibrium. So you can write that at stable equilibrium, the potential energy will come out to be minimum, and that will be minus Pe. And in unstable equilibrium, theta will be equals to 180 degree, cos theta will be minus 1, potential energy will be maximum, that will be plus Pe, and this will give you unstable equilibrium. So some simple questions are there. Suppose your dipole was initially at 60 degree angle with the electric field, and now you have to rotate it further by 60 degree. So work done by external agent and work done by electric field to shift the dipole from initial to final position. Very simple. Work done by external agent will be final potential energy minus initial potential energy. You can use this formula for potential energy at any angle theta, you can get the answer. And work done by electric field will be negative of work done by external agent. This I already told you. So this is how you can calculate the concept of potential energy. So with this we have completed the concept of potential. Potential part is over for us. Potential energy wala part, that is completely over for us. Now let me discuss the concept of capacitance and capacitors. Actually, in this chapter is broken into two parts. One is the concept of potential energy and all these things. And once we know all these things, then the next part is the concept of capacitance or capacitors. So how to define a capacitance? I've already written some theory here so that you understand. What is a capacitance? Basically, it is a capacity. It is the capacity of a metal or conductor to store charge. See, I think when you would have done previous chapter, you would have done some properties of conductors. So basically, conductor is a material which allows free charge to move. Whenever you will give any free charge, any excess charge to a conductor, it will reside on the boundary of the conductor or on the outer surface of the conductor. Now, how much charge you can give, based on that, the capacity to give the charge to a conductor is basically called as capacitance. If you can give more charge to a capacitor or more charge to a conductor, then that particular conductor will have more capacitance. If some less charge you have to give, then it will be less capacitance. So it is the capacity of a metal or conductor to store charge. The metal which has less capacity to store charge is having less capacitance, more capacity, more capacitance. And if you think that conductor can store infinite amount of charge or it can have infinite capacitance, then that is not true. Why? Because suppose you are taking metal like this and it is having some different shape. Now the charge density of this shape actually depends on inversely proportional to the radius of curvature. That means wherever there will be sharp edges, at that point the sigma will be very high, at that point electric field will be very high. You already know that whenever we talk about electric field due to a conductor, it will be always perpendicular to the surface, and this electric field will be given by sigma by epsilon naught. So where will be the electric field strong? Where the sigma will be strong. Sigma is stronger at this region, so electric field is also stronger in this region. So what will happen is that as you are giving charge, electric field is increasing. As electric field is increasing, what will happen? It will basically, at one point, it will basically disturb the insulating medium. It will break the dipoles of the insulating medium, and the medium will also become a conductor. Once the medium will become a conductor, then you cannot give further charge because now the excess charge will leak into the surroundings. That is why there is a maximum capacity to hold this particular charge. So if somebody will ask you that can a conductor have infinite amount of capacitance? The answer is no. A conductor cannot have infinite amount of capacitance. Now how to calculate the capacitance of a conductor? And one more thing, there is a concept called as breakdown voltage, that also let me tell. See, what actually happens is, if you give charge to this particular metal, then the electric field value at which the surrounding medium will become a conductor, that is called as dielectric strength of the material of that particular medium. The voltage at which this particular breakdown will occur, that particular voltage is called as breakdown voltage. So what is written? Potential of the metal at which its insulating surroundings starts to behave like a conductor is called as breakdown voltage. So obviously if the medium is stronger, its breakdown voltage will also be more, because it will be difficult to make it into a conductor. So this is basically the things which I have given. Acha, one more thing, capacitance of a metal depends on what? It depends on shape, size, geometry of the metal. It also depends on the surrounding medium. If the metal surface is flat, capacitance will be more. If it is sharp, capacitance will be less. Why it will be less? Because if it will be sharp, then electric field will become very stronger, then easily the breakdown can happen. Okay, so this is basically the concept of breakdown voltage. Now how to define the capacitance of a conductor? Suppose if you are having a metal and you gave Q charge to this, so obviously the charge will not be inside the bulk of the material, the charge will reside on the surface of the material. Suppose the potential of this particular material is V, and obviously this V is with respect to infinity, because by default I am bringing the charge from infinity only. So capacitance will be defined by what? Capacitance will be the charge on the conductor divided by the potential difference. And for a given capacitor, always remember, for a given conductor, the capacitance of the conductor will always remain a constant. It will not depend on charge, it will not depend on potential difference, it will always be a constant. What will be the unit of capacitance? It will be coulomb per volt or farad. The practical units are microfarad and nanofarad. See, 1 farad is a very large quantity, so we don't have to take that. Capacitance of a metallic sphere. How to calculate? Whenever you want to find the capacitance of any system, there is only one method to find the capacitance. Find the charge which you have given to the conductor divided by the potential difference. Potential difference between those 2 points between which you are transferring the charge. Here by default you are transferring the charge from infinity to this surface, so potential difference between these two will come. So suppose you are having an isolated metallic sphere of radius r and you are bringing charge from infinity to this point. Capacitance will be given by Q divided by V, and V can be written as KQ by R. We already know that for a conductor the voltage can be written as KQ by R. So capacitance will come out to be 4 pi epsilon naught R. If the entire space is filled with any other medium of dielectric constant K, then you can write directly it will be 4 pi epsilon naught into epsilon R into R. So it will be K times of the individual capacitance. I hope it is clear to you. Next. So if they will ask you what is the capacitance of Earth, because Earth also can be considered as a huge conducting sphere. So capacitance of the Earth comes out to be 711 microfarad, which is a very less capacitance. That is why I told you that 1 farad is a very large unit. Generally we don't use that particular unit, we use only microfarad or nanofarad capacitors. Now what are the drawbacks of an isolated spherical capacitor? Why it is not used as a capacitor? Because here there are two problems. First problem is, whatever electric field is there, it is basically distributed from surface to infinity. The electric field is distributed from surface to infinity. And we already know that electric field carries energy with it. Electric field actually carries energy with it. So if the electric field is distributed from surface to infinity, the energy will also be distributed from surface to infinity. But we want such a device which can store some energy and in a confined space, and whenever we require that energy, it should be able to give us. That device is called as a capacitor. Here the energy is distributed. And second thing is, the capacitance value is very less. It is having very less value, so we will not use this as a capacitor. So this is the problem. So how we will define then two capacitance and all those things we will discuss. But before that, let me discuss one more case in which, let us suppose there are two conductors. One is having capacitance C1 and one is having capacitance C2. And let us suppose I have joined these two conductors with the help of a wire having some resistance. After some time, what will happen? Initially, let us suppose that this was having higher potential and this was having lower potential. So initially what will happen is the charge will flow from higher to lower potential on its own. And finally, after some time, the potential between the two conductors will become zero, potential difference will become zero, or potential will become same. So they will ask you what is the common potential of this system. So common potential will be given by C1 V1 plus C2 V2 divided by C1 plus C2. Please remember this result. How to calculate this? Very simple. Finally potential will be same. So suppose final charge is small q1 on this and small q2 on this. So small q1 by small q2 will be in the ratio of capacitance value C1 by C2. And you can find the common potential also, C1 V1 plus C2 V2 divided by C1 plus C2. If you want to find the heat dissipated, because obviously if charge will flow through a wire which is having some resistance, some heat amount will be also dissipated. So how much heat will be dissipated? It will be given by U initial minus U final. The formula will be half C1 C2 by C1 plus C2 into V1 minus V2 whole square. So this is how you can basically calculate the value of heat dissipated when you connect two conductors having capacitance C1 and C2, and you can also find the common potential between them. I hope this point is also clear. Next is basically a parallel plate capacitor. So capacitor is what? Let me tell you. Capacitor is basically a device which is used to store energy. How it will store energy? There will be two conducting surfaces. Those two conducting surfaces will be in front of each other. Their surfaces will be facing each other. You will give positive charge to one of the surface and equal and opposite negative charge to another surface to charge the capacitor. And then whatever energy will be stored in this capacitor will be confined in this particular region between the two surfaces. So basically what is the capacitor? Two metals or conductors placed near to each other is called as condenser or capacitor. It is an arrangement which stores charge, electric field and electrostatic potential energy. So capacitor is an arrangement of two conducting surfaces placed in front of each other which can store energy also, which can store charge also, all these things it can store. So there are different capacitors which are being made. The very important capacitor is parallel plate capacitor. So parallel plate capacitor will bring two infinite charge to infinite plates, conducting plates. They will be placed very close to each other. Suppose the distance between the plates is d, and let us suppose the area of cross section will be a. On one plate you will give positive charge, on another plate you will give negative charge. What will be the capacitance of this system? It will be equals to, capacitance will be equals to C is equal to epsilon naught A divided by D. Epsilon naught A by D. If the entire system you have filled with a material of dielectric constant epsilon r or k, then in that case the capacitance will become k times or epsilon r times. So please remember this result. For parallel plate capacitor it is very important. The capacitance is given by epsilon naught A by D. So I hope this is also clear to you. Now based on that, there are some questions based on this. Like one more thing, capacitance actually will not depend on what? It will not depend on charge, it will not depend on potential difference. Capacitance of a system only depends on the area between the plates, the medium between the plates, and inversely proportional to the distance between the plates. One very important question is that if you are having two capacitor plates, on one you have given a charge q, on another you have given a charge minus q, they are asking you that what is the electrostatic force between the plates. By obviously one plate will apply a electrostatic attractive force na. So how to calculate the force? Force will be equals to the charge on one of the plates. Suppose I am finding the force on this minus q plate. So the magnitude of the charge on one of the plates multiplied with the electric field due to the other plate. Now due to one plate we already know that the electric field is sigma by 2 epsilon naught or q by 2a epsilon naught. So the electrostatic force will actually come out to be q square divided by 2a epsilon naught. So this is a very important question which you have to remember. Please remember it. I hope it is clear to you. Let me discuss the circuit solution also of RC circuit. वैसे this RC circuit topic actually I am not discussing right now because this is the topic of the next chapter, that is current electricity. In brief, let me tell you that in RC circuits you have to take two conditions. Whenever a capacitor will be initially uncharged and it will be connected with a resistor and a battery of EMF E, then basically at t equals to 0, just after closing the switch, suppose there is a switch here, at t equals to 0, just after closing the switch, the capacitor actually behaves as a short circuit if it is initially uncharged. Remember, if it is initially uncharged, the capacitor behaves as a short circuit. The overall capacitance, you can replace it with a short circuit wire and you can find the value of current, that is E by R. If you charge the capacitor as the capacitor is getting charged, then at steady state what will happen? At steady state, the capacitor will behave like a broken wire or an open circuit, and if it is behaving like an open wire, the overall current in the branch which is containing the capacitor will become 0. So two things you have to remember. First thing is that whenever at t equals to 0 you are closing the switch, the capacitor will behave like a short circuit and the current will be E by R. And if you are taking the steady state when the capacitor is fully charged, the capacitor will be like a broken wire or open circuit, and in that particular case the energy will be stored in the capacitor but it will not allow current to flow through it. So two things if you remember, you will be able to calculate the cases. So with this we have completed this part also. Now let me discuss the series and the parallel combination of capacitors with you. So in series combination, again I am not deriving it, just few things which you have to remember I am telling you. Whenever we will be discussing series combination, always remember in both the conditions, whether you are doing series combination or whether you are doing parallel combination, in both the cases, the capacitors should be initially uncharged. Capacitors should be initially uncharged, then you are charging the capacitors. So in series combination, the equivalent capacitance will be given by 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. And the potentials will be in the inverse ratio of the capacitance. So V1 is to V2 is to V3 will be 1 by C1 is to 1 by C2 is to 1 by C3. What will be the energy stored? Total energy stored will be Q square divided by 2 into C equivalent. And if two capacitors are given in series, then directly you can write C equivalent as C1 C2 divided by C1 plus C2. When we are discussing about the parallel combination, then in the parallel combination, C equivalent will be given by C1 plus C2 plus C3, and the ratio of the potential energies will be C1 is to C2 is to C3. Here the energy is directly proportional to capacitance, and here the charge is directly proportional to the capacitance. So basically the total energy can be written as half C equivalent into V square. If two capacitors you are taking in parallel, then in that case the total charge will be Q1 plus Q2, and the ratio of the charges will be in the ratio of capacitance, so you can directly calculate the charges. C equivalent will be given by C1 plus C2. So this is how you can calculate the value of capacitance. So this was some basics of series and parallel combination. Dielectric, I already told you that in dielectrics what happens? In dielectric materials, whenever you will insert dielectric in between the capacitor plates, total dielectric which you are inserting, the capacitance will become K times. The capacitance will become K times. Now this is very important. There are two special cases which you have to remember. In the first case, initially there was some capacitor plates. I charged the capacitor with the battery, then I disconnected the battery, and then I inserted the dielectric. So battery is removed and dielectric inserted. In this case what will happen is, the charge on the capacitor will remain same. You have removed the battery now. If you have removed the battery, what will happen? After removing the battery, the charge will remain same, because there is no path for the charge to move. What can you tell about electric field? Electric field will basically become 1 by K times, because we know that the net electric field is given by sigma by epsilon naught, that is Q by A epsilon naught. So basically the electric field will become 1 by K times. What will be the potential difference? Potential difference will be QD by A epsilon naught. Since electric field has become 1 by K times, so potential difference will also become 1 by K times. Capacitance, I already told you, it will become Kc naught. Energy stored, because we know that energy stored is Q square by 2C naught. So here it will be Q square by 2Kc naught. So energy also will become 1 by K times. So please remember this particular table. It is very important based on that. Now, if battery is connected and you have removed the dielectric, then what will happen? Battery is connected and dielectric is inserted. In that case, what will happen is, the potential difference will not change now. Potential difference will remain same, because you have not disconnected the battery. So finally the capacitor voltage will be equal to the battery voltage. Electric field will not change. Why? Because potential difference is same, D is same, so the net electric field will always remain same. Capacitance, obviously it will become K times. Charge is basically C into V. Potential difference is not changing, but capacitance has become K times, so the charge will also become K times. What can you say about the energy stored? Initially it was half C naught V square, now it will be half K C naught V square, so the energy stored will be K times of U naught. So I hope this is clear to you. Now two cases, whenever multiple dielectrics will be inserted, how do you have to do? If they will insert the dielectric like this, they have taken the area to be same, but the distances are different. In that case, it will represent to a series combination. You can convert this system as two capacitors in series. One is having dielectric constant K1, one is having K2. So C1 can be written as K1 epsilon naught A by D1, C2 can be written as K2 epsilon naught A by D2, and then you can apply series combination. So when will the series combination be applied? Whenever there are two plates or two dielectrics and the distances are divided but the area between the plates remains same. If this type of combination is there, like this type of combination, in this case what will happen is that this case it will represent to a parallel combination, because now the area is divided. If you see, the area here is A1, here it is A2, but the distance is same. So this is parallel combination, and in parallel combination you can directly write C is equal to C1 plus C2. Now please remember one thing, in this part where more than two dielectrics are inserted, there are two ways to do this. Either you can take these two in parallel, and then in series, or you can take these two in series and these two in series and then in parallel. Actual is this one. Second part is the correct answer. Please don't take these two initially in parallel, because you don't know whether there is same potential difference between these two dielectrics. So always remember, this will be the correct option, that take these two in series, and then you take the combination in parallel. If you partially fill capacitor with dielectric having thickness T, In that case, the capacitance will be given by epsilon naught A. Let me write also. Capacitance will be given by epsilon naught A divided by D minus T plus T by K. So this is how basically you can calculate the capacitance. I've taken mostly all the cases based on the concept of capacitance also. And with this, I will complete my lecture. I hope this particular lecture I have taught you many things. Please do all the questions whatever I have given you, and please revise these particular concepts, and I hope this particular lecture will be useful to you. Thank you very much.